So first we will define what is power. So power is rate of doing work. Okay. So at whatever rate the work is being done, that is called power. So we will define, we will see its examples. So rate of doing work is called power. Okay, so how fast a machine or a person can do work, that will be its power. Okay, so if you see different machines, suppose you see different motors, or if you see the vehicle, car, bike, so all these machines are having some power rating. Okay, so power rating means what? So they are provided means they can give this maximum work, the maximum work per unit time they can give up to this much amount. So that is the power, maximum power of the object. So generally you will see the units at horsepower. Horsepower is the unit of power. Okay, so this much this much rate they can do the work. So the definition is the definition of power mathematical form. If you write, it is dw by dt. Okay, and its unit will be what? The work has unit joule, so it will be joule per second. Joule per second or watt. That is in the name of James Watt, who discovered the steam engine. Okay, so James Watt, the watt is in the name of James Watt, and who discovered the steam engine, who not discovered, sorry, who invented the steam engine. And this is defined as, the watt is defined as 1 joule of work done per unit second or per unit time. 1 joule work done per second. Okay, so this is definition of watt. And you will see different unit. There is one more unit that is called horsepower. Horsepower. Okay, so what is this horsepower? So it is written as HP. In short, it is written as HP, and it is 746 watt. Okay, so in old days, people were measuring all the things in terms of the horsepower. So horsepower means, so you will have a horse, and the horse will means how much the horse is doing, able to do the work. So on average, they would have calculated the horse is able to do this much amount of work per unit time. So from there, they would have defined this unit. So that unit comes out to be 746 watt. From there, they have defined the horsepower. So in Britain, this was the unit most, the unit was, the famous unit was horsepower. Okay, and this is the, what is SI unit, and horsepower is the British unit or FPS unit. But if you see India, in India we were having something called elephant power unit. So those things you can see in the various episodes of Ramayana and Mahabharata. If you see the various episodes of Ramayana and Mahabharata, there you will find the terms. They use the word that person Bhim is having a power of 10,000 elephants. Okay, or that some other person Duryodhan is having power of 1,000 elephants. So that is the example. Means in old days the people were using the unit of power with elephant power. Okay, so elephant power was used in the India as well at that time, and in the Britain it was horsepower. So now you can see how it is related with our present day power. Okay, so now in motors you can see the horsepower is still famous units. Okay, so in motors you can see that electric motors, you can see the power rating of 1 horsepower or 1.5 horsepower. Okay, so this kind of unit you may see in the different machines. And in tractors you will have, generally tractors are having very large amount of power. So in tractors you may see up to 50 horsepower, 60 horsepower, like that. So truck and tractor you may have like that. In bikes you may have 1 horsepower maybe. Okay, so this kind of unit is there. Now we will define, we will try to elaborate this thing more. So since it is dW, so dW is what? Work. So work we can write as F dot ds. Okay, so if we write it further, we can write as force dot velocity. Okay, so the power is also defined as force dot velocity for a translating object. So if an object is moving, suppose an object is moving and it is exerting a force F and its velocity in the direction of force is V, then we can write the power as F into V or Fv cos theta if the velocity and force are not in same direction. So where it is applied, in what kind of situation this is applied? Suppose a person is running, okay, while running, after acquiring the maximum speed, he will run with the constant speed. Whatever maximum speed he acquired, now he is running with the constant speed. So the net force on him is zero now. So net force on him is zero. Why? Suppose a person is running. The net force on him is zero after acquiring the maximum speed. He is running with Vmax. So there will be a friction force acting from the air, and then he will exert a force in forward direction. These two forces will cancel. The friction force of air, the air friction, and the force in forward direction. These two will cancel. Okay. So how much is the force exerted by man? We can calculate. Okay, if the friction force is given. So we can, if we know that how much force the man is exerting and whatever is the velocity of the man, if you multiply these two, we can find how much is the power of the man. Okay. So in this way, we find the power of a running person. Okay, so we will see a problem based on that. Or for motor also we can find. We can relate this thing with more. Suppose we elaborate this further, and power is given by what? Power is given by work per minute time. And now work we can write as what? Change of kinetic energy plus change of potential energy. So can we write it as like this? Suppose this work is being done from some machine, so from outside. So this is suppose external work. Okay, so that we can write as delta K plus delta dW as dK plus du divided by dt. So we can write as dK by dt plus du by dt. Okay, so power is also given by the rate of change of kinetic energy of object plus rate of change of potential energy of object. Suppose an object is being lifted on a inclined surface and its potential energy will be increasing as it is going up. Suppose we have an inclined surface and object is being pushed by some external force. So it is being lifted, so its potential energy is increasing at some rate, and if its velocity is also increasing, then its kinetic energy is also increasing. So the rate of change of kinetic energy plus rate of change of potential energy will also give the power exerted by external force. Okay, so this can also be used. So these are the formulas, and we are going to use this formula for solving some problem.